Hello guys, today I'll be doing uh, MATLAB Simulink circuit or SimScape circuit of a RLC circuit. So as you can see here, I have a RLC circuit here. It's a simple RLC circuit which is a second order system that I'll be simulating in MATLAB Simulink. As you can see, I have my inductor values, the resistor values, and capacitor values. In this case, my input is from the inductor and my output voltage is across the capacitor here. Then I have my differential equation here already calculated them for the input voltage and the output voltage. Then using these two equations I calculated my transfer function, as you can see. So let's start with this circuit in Simulink with MATLAB Simulink. So I have here my MATLAB open. As you can see, this is where I have the Simulink here. If you don't have Simulink in your MATLAB, you can go to get add-ons. Just wait for it to load. And in add-ons, you can type in Simulink. That will give you the Simulink designer here. Then you can click on it and just install it. I already have installed, so it says it's installed. That's how you can get the Simulink. And uh, for this simulation, you also need a Simulink toolbox or a package for electrical circuits. So you can also type in Simulink electrical. Yeah, as you can see, if you just type in electrical, gives you SimScape electrical, which I have already installed, and even this SimScape that helps to transfer that will be used in this simulation. Yeah, so just make sure you have these two libraries installed for Simulink. And if you have everything, then you can double click on Simulink. You can open, then you can open a blank model. Then here I have my Simulink open. So as you can see, this is my Simulink. Here I have my taskbar, you can say, my simulation where I can simulate things. I have my stop time, how long I want to run for my run and other stuff. Then debugging if you want to, if your model is not working, and there are others. You can go through it yourself. So first thing we'll do, in the new Simulink, the good thing is you don't have to always go to the library to look for your components. Like I have my library here where if you click here it shows you your components, and if I scroll down, Simulink designer, so yeah, here in Simscape I have my electrical toolbox where I can find different components. As you can see, Simscape, that library, and then find it from there. You can, what they call, you can bring in the components using your, what do you call, your library. Let's see, if I select observer, then I just click on it and drag and drop. Just let's just wait. So as you can see, it drops it here. Then if I click on it, I can move on Simulink. That's one way to get your component. Another way is just you click on your anywhere on your screen or in Simulink, you just click and you just type the name. Let's say I want a resistor. And as you see, it gives me the resistor there. So there are two ways to get the components, either library or you can just type on the on your screen. I like using the way I would like it. It's just type it on the screen. Then I will look for an inductor here. As you can see, there is the inductor. Then I need a capacitor. Then you have the capacitor. You can change its orientation or rotate it by pressing Control R. That rotates the capacitor. So you can rotate the or any other component, whatever orientation you want. Just select it and press Control R. Yeah. Then you can do it like that. Then if you double click on these components, then this is where you can set your values. Like this inductor is 1 microhenries, as you can see. Then even on the resistor you can do the same. And you can also find these uh, components on the library. You can type here, and then it looks for your resistor. And as you can see, I have some of the components here. Then you can select this, drag and drop. Yeah. And if you want to remove the component, you can select it or press delete on your keyboard. That's for me the easiest way to remove any component I want. Then I have that. Then let's go back to um, say, our circuit. So our inductor value 0.3 Henry, resistor 50 ohms, and capacitor 15 microfarad. So let's plug those values in. Then I can select my inductor to be 0.3. And when you're done, then you just press enter. Then you can close it. 0.3. And again I select my resistor, which is 50. Just press enter. It's there, 50 ohms. You can close that. Then even my capacitor, which is 15 microfarad, so I just replace one with 15. Yeah, because e to the power of minus 6 is same as 15 times 10 to the power of -6 in MATLAB. Or if you don't want to write that, then you can come this side and select 50, then microfarads. Yeah, it's your choice how you want to do it. Then you can press enter. Then we close that. Then we need a voltage source. As you can see, we have our voltage source here for the circuit. Then you just select the wire from there and connect it, same as here. Just drop it and it just connects. As you can see, I already have a circuit something like this, you can say, which you can just check. Then you need a ground here. Then you say, I can type electrical reference. which I just connected there. Then I need to solver configure. In some for this circuit you do need this solver configuration, else your simulation doesn't work properly. Yeah, so that's why you use the solver configuration. Now you can see I have my circuit here, then I select my voltage source. In this case I just want a step response of the system so we can see what kind of graph does it use and those things. So my DC voltage I just select it to be 1, I press enter and you can close that. Now to measure the voltage across the capacitor we need a voltmeter or a voltage sensor. You can just click anywhere on the screen, just type voltage sensor. So this is your Simulink equivalent of a voltmeter which you can connect across the capacitor like so. Then to this is you see this small this is where your data will come in. So we want this data to be converted into Simulink data, physical scale to Simulink. So to do that, you just type in PS to Simulink converter, and then that will be connected there. That it converts this electrical or physical scale data into your Simulink data. That's what we want. Then we can uh, display this data either on a scope or we can save it in a workspace. So we'll have these two. You can tap on the screen scope. You just connect it. Then we need also workspace. Then you can also connect that. Then workspace you can just select. Double click on workspace. Then you can uh, let's have this. You can change the name here. I'll just say out voltage. And then my limit data points is infinite. I have infinite data points. Then my saving format, I'll save it in a array. And I'll make this 2-dimensional. Then my sampling rate, you can say here sampling rate when they say -1, so it takes a default sampling. I want it to be 0.001. Then you can just click on it and apply. Press OK. So what happens is this workspace is created in MATLAB. If you go to variables, open variables, you don't have it here, but when you run the simulation, you will find. Let's we clear the work circuit here. You can also double click on it, then just select, then you can relabel it L equals. You can type the 0.3 Henries. And then our resistor we can take as R equals 50 ohms. Then our capacitor you can also change that name. This is C equals 15 microfarads. Then we have that. Then you can also change this our voltage source. You can call this VI and this is V out. So that we can label our components like that. Yeah, then from there we can run our For this case, I have selected 10 seconds to run the simulation of let's say just in uh, yeah, for 10 seconds. Let's run. Yeah, then you can see it starts compiling, checking for errors. Then when it's done compiling, it's done running. And if you double click on the scope, it gives you this graph. As you can see, it's a bit, the 10 second is too long. Then you can, let's reduce it. Maybe 1 second, I believe, should work. Then you can open your scope, and as you can see, we do get the graph here. Let's make it more smaller. 0.2. Then as you can see, it does give us a nice graph here. We have some, what do you call, an overshoot, undershoot. Then after some time it dies out and stabilizes. Now if you want to do analysis on the graph, you can find, let's say you want to find its peak or what's the period of the graph and everything. Just go to tools, measure. Then you have cursor, measure, signal, statistics, your measurement and other stuff. Let's select one of them. Then you see when you select, let's click by level measurement. Then it gives me my highest value. No, it's high. Yeah, you can see it's the high, then the low, then how many edges it has. Then it gives you your rise time, your slow swell the rate and other stuff. Then if you click here, gives you a pre-shoot, overshoot and undershoot. And if you select it, it gives you other information. And if you go to settings, you can change here and where you want to measure. You can come here again and let's unselect that. Signal statistics. Then it gives you a maximum value, your minimum value, and your peak to peak value, your mean, your median, and your RMS of the signal. Then other information, so you can get these informations for the signal at this side on the graph. Then you have this workstation here. So this data is stored in MATLAB now. So if you go back to MATLAB, then you check on variables, open variable, then you see we have this variable here which is called out. So that's from MATLAB. And if you open a live script, then you can use that variable here. So let's say now we want to plot that graph into MATLAB here. Then you just say plot. You go to the out, you select the variable out, then on the out you see you have your data here which is out voltage they call it. So in your plot you just type out dot, it's like a pointer variable, then you just type out voltage. So it's dot, then it's a point. It's pointing to, let's say out is like a structure, then points into the structure. The data is stored in auto voltage. Then from there you can go to live script, run. Then as you can see, it does give you a graph something like this. And we have this sharp punch due to the sampling rate we have, which we can change here. We can make our sampling rate higher, let's say 0.001. Then if we apply and let's run it again, then you see it's more smoother now because we have more data points. Then you can go to MATLAB. Then again you can run the same graph. Then you see it's more smoother because we have more points now. Yeah, so that's all. Then you can also format like this. If you want to see grid, just say grid on. Gives you the grid, and let's say we want the title. And we say step response RLC circuit. Then if you run there, then it gives you a heading there. Then you can also type your X and Y label. It says X label. Then your it gives you a Y label. So X in you can set time. Then your Y label you can set your voltage or output voltage. Voltage. And if you run again, that gives you a nice graph here. Then I think you should type in step ST step info. That should give you the information about the graph, or your rise time and those things. Yeah, and as you can see, if you use this function here, step info, it gives you all the data, rise time, the transient time, settling time, your overshoot percentage, your peak volume, and everything of information about the circuit. Just and then you can just see, just by constructing this circuit and simulating in Simulink, that gives you almost all the data you want on, even on MATLAB, using workspace, getting your data from workspace. Yeah, so I would say try other circuits on Simulink. It's a powerful tool which you can use to simulate a lot of stuff, because I think so for now what I've just shared, it's very basic. You can do more stuff and more powerful things on Simulink, using design more things or more complex systems on Simulink, such as a power grid system or a PV system, and the other stuff which you can do using just MATLAB and Simulink. So it's a powerful tool. So I would recommend go do your more research, play with MATLAB and Simulink, and see there are a whole lot of things you can do. Yeah, alright. Thanks, guys.